All right. I think we can go live. Hello, everyone. I am so excited for this code along today, or prompt along, as we say, given that we're going to be using ChatGPT O1 to build some applications today. I am so excited for this one. Everyone, do let us know where you're joining from in the chat and what you're looking to get out of today's code along. Um, I've designed the code along in a way that we're able to, use a Google Colab notebook to be able to kind of build a bit of a useful web app that lets us look at stock data, right? And I'm going to get to that shortly. But if you have any other ideas that you'd like us to design in a Google Colab today, let us know as well. Maybe we'll have time for it as well. I'm going to share screens and I'll get started. But already seeing here folks joining in, letting us know if they're joining. See Lydia. Hello, Lydia. Where are you joining from? Indu, same thing. Everyone, do let us know where you're joining from. I'd love to show these on stage. Oh, like this one, for example. So yeah, Artsum as well. Hello, great to see you. So I'll get started and I'll keep a lookout on the chat to make sure that we showcase all the wonderful people that have joined here from all over the world. Really excited for this one and really appreciate everyone's time. So let's get started. So we're going to build applications today with ChatGPT O1-preview. And what I mean by applications, we're not going to be building mobile applications, but we're going to be building a useful tool for us that can be applied in a work context. So I'll get started here. People are joining in from all over the world, I see. So we have Bruno from Brazil, Margot from Canada, Confidence from Nigeria, Long from England. Lydia is joining in from Paris. Bonjour, Lydia. Lived in Paris for a few years, actually. Indu from India. Raul from Cambridge. Oh, wow. People are joining in from all over the world. Ken from Sweden. Chapo from South Africa. I think we're covering most of the continents by this time. So we have definitely Asia, Europe, um, the United North America, South America, right? Africa here as well. Zimbabwe, Bridget, great to see you. We have Anita from Romania, Bună ziua. Ayub, bonjour for tout le monde, which means good morning, everyone. Great to see you here. Amazing. We have people from all over the world. It's great to see again. It's truly a pleasure. And we have Sahil here from Australia, and I think we're rounding out. Constitution is joining from Antarctica. This could be a first, but this could also be a troll. So I don't know. But awesome to see people from all over the world. Amjad from Egypt. Marhaba, Amjad. Great to see you. And yeah, amazing people from all over the world. It's amazing to see, and very excited for this particular session today. So we're going to be talking about how to build applications with GPT O1, with ChatGPT O1, which is the OpenAI O1 model. First, I'll give you a bit of an introduction about myself. My name is Adel. I'm VP of Media at DataCamp. I host the Data Frame podcast. I help co-organize a lot of these webinars and code-alongs. I have the privilege to be able to work with such an amazing team here in the Media team to be able to create these experiences for you. And yeah, I'd love your feedback over how we can make them even better throughout the session. So what are we going to talk about today? I'm going to give a bit of an overview of why ChatGPT O1 is a bit different than your usual ChatGPT. Why the O1 model is a bit different than the usual GPT models. In a lot of ways, it's in the name, right? OpenAI created the O1 model. It's not GPT-5. It's a different model. I'm going to show a few examples of coding use cases from ChatGPT O1, and we're going to try out one in production, right? Right here. We're going to build a snake game with ChatGPT O1 directly in HTML. And then we're going to have a bit of time for questions. So if you have any questions before we start the prompt along, do make sure to ask them. And then what we're going to do, because, DataCamp, we're really focused on data skills here, right? I would like to build a web app in a notebook environment that lets you analyze financial data, right? And what we're going to build is three elements of a web app. One that shows a price sticker, a kind of a price chart that we can edit and play around with. for a few different stocks. Then we're going to go even beyond that and show a few additional measures, financial measures for a particular stock, right? And then we're going to build a pipeline that takes financial news data and analyzes sentiment for that data. And the outcome is just a data frame, sorry, with a title and the sentiment of that article. And it shows here to illustrate what is the art of the possible with tools like ChatGPT O1. And then we're going to have a bit of a discussion on when to use O1 versus other models, right? And then we're going to have some closing notes and Q&A. Now, this is someone just asked this, Constitution just asked this as well. To be able to prompt along, you do need to go on chat.openai.com, right? To sign in. I think most people should have a ChatGPT account. But given that we will be using O1-preview today, you will indeed need ChatGPT Plus or Teams or Enterprise to be able to access the O1 model, right? If you don't have O1, that's okay. There's still a lot of value here for you. You can probably try a lot of these prompts as well in GPT-4o, right? And then see how it performs as well for you. And I'd love to see your experience as well. Do you get the same results? Is O1 overhyped here? So with that said, let's get started. What is different about ChatGPT O1 preview? So here it's in preview because it's still in a relatively beta model. But what is different about the O1 models, the O1 family of models in general? So first, I'll give some introduction and some background on how ChatGPT works in general in like large language models. I'm not going to go deep into the math. One, because I am not a machine learning PhD. And two, because I'd rather give the intuition here rather than go deep into the math. So ChatGPT and large language models in general are based off of something called the transformer architecture. In a nutshell, the transformer architecture is a type of model within deep learning, which is a type of artificial intelligence or machine learning. And generally, at a highly intuitive level, there's a lot more that goes on in a transformer architecture, but there is three kind of ingredients to the transformer architecture. One is the encoder, the decoder, and the attention mechanism. So the encoder, what it does is that it takes an input. So here, for example, we're giving a use case of translation, right? It's a sentence in English. It processes it and transforms it into a way the model is able to understand, like a representation of language in a way the model is able to understand, right? And it tries to capture the meaning of the input sequence. The decoder takes what the output of the encoder, right, which is the representation of the sentence here, how are you, and turns it into the desired output. For example, translating the sentence into French or Spanish, right? And what the attention mechanism does, right, which is kind of the secret sauce of the transformer model, right, helps the model understand the relationships between words and allows it to focus on different parts of both the input and output to be able to make really coherent and statistically likely, right, meaning in the output, right? So here, for example, the input was "How are you?" The output was the Spanish translation of "Cómo estás?" Right? Um, and then if you think about it, how it works in action when you work with ChatGPT, right? The model's already pre-trained, right? So those encoded, decoded relationships are already, computed between the different data that the model has been trained upon, right? You prompt it. So here the input would be to the model, can you translate this sentence into English, into French or Spanish, right? The model then looks at the relationships between the input and the output, given the desired output, and then produces that output, right? And a lot of ways, GPT stands for Generative Pre-trained Transformer. I'm trying here to give a very intuitive explanation. So when you say something like translate hello into Spanish and you come out hola, for example, or where you say write an essay on data science in the style of Shakespeare, right? Or transform this pandas code into R, right? The model's finding relationships between the input and output and giving you the most statistically likely answer here. So you can say in a lot of ways is that LLMs are next token prediction machines, right? They're not necessarily very good at reasoning. So what they try to do is they take the input and produce, which is the prompt, and produce the output that is most statistically likely relevant to that input, right? Which is why, in a lot of ways, large language models are not really effective at reasoning or agentic workflows yet. So, big kind of release over the past year is the kind of tool called Devin, right? Which was, touted as an automated software engineer. It's able to decompose a problem into a small one, and it's able to build, a solution for an application, right? And this is not me trying to dunk on Devin, right? This is just a sign that the technology is not yet there, uh, according to many experts and people, right, who have tried and reviewed this tool, right? And you can see it because the underlying model that powered them, or the underlying generation of models at the time, also did not have strong reasoning skills, right? So here you see that there's it's cut off. It's cut off for a reason, because I'm coming to the next slide, right? A GPT-4o, which is the best model available on the planet before O1 at the time, right? Or one of the best models, right? Between Claude 3.5 and Llama 3 and all these things, right? Had a 13.4% accuracy on a math competition, right? 11% accuracy on a coding competition, right? And did 56.1% compared to a human expert that did 70% in answering PhD level science questions, right? And this shows you that LLMs are not necessarily great at reasoning, but they're just great at producing the most statistically likely answer given the input that you give it, which makes it prone for hallucination and um, wrong answers, right? It also, who's noticed before when you ask ChatGPT to code something, it sometimes doesn't give you the most efficient way to solve a particular solution, right? So that's also, a symptom of that. Now, what O1 does is that it combines the power of transformers with something called reinforcement learning, right? To push us on that frontier forward of LLMs that can reason. Now, I'm not saying that we have cracked intelligence, but O1 does exhibit better capabilities to decompose problems into smaller ones and to be able to find the most effective solution for a given problem, better than the previous generation of models. So reinforcement learning, what is this? Kind of to explain the intuition behind it as well. It's a paradigm in machine learning that allows an agent to achieve an objective in a given reward, in a given environment, to maximize a certain reward. A great example here would be like a chess playing AI, right? Um, you have an agent, which is essentially the software, right? It needs to it needs to win a game of chess. It's trying to maximize its score given the environment and the move limitations it's in, right? And in a lot of ways, for those who are more aware of this, the model that um, is responsible for the model that is responsible for a DeepMind winning the game of Go, right, is a reinforcement learning model. Now, the second aspect that makes O1 successful here is chain of thought reasoning, right? It's a technique that breaks down complex problems into smaller, more manageable components, right? Um, and then they're able to use both reinforcement learning to be able to identify what are the most effective solutions given a problem, and then chain of thought reasoning, which lets the model decompose big problems to small problems to effectively solve more open-ended issues, right? And then finally, compute allocation, right? Traditionally, LLMs have been primarily focused on massive pre-training data sets, so a lot of the compute goes to pre-training, right? But O1 shifts the emphasis here towards the inference and training phases, right? So a lot of the compute allocation goes to actually producing the answer, right? Which is here train time. We should see it here in the graph on the right, shows the more compute given, the better the accuracy given at these phases. And what that looks like in action for O1, right, is that if you say, you give it a very famous puzzle like the Monty Hall problem, right, what it will do is that it will think, right, and it will try to break down the problem into multiple problems, and we'll see that in action shortly. Now, given that we've just discussed that O1 is pretty good at reasoning, what that means is that it's much better at code, right? So we saw that earlier slide where I had hidden here these bars, right? On the math competition, right? GPT-4o did 13.4%. O1-preview, which is the model we're going to use today, did around 56.7%, right? And then O1, which is the model that is not yet released, right? That's not the preview version, is 83.3%, apparently. On code competition, GPT-4o did 11%, O1-preview 62%, and O1 89%, right? And the crazy one here is PhD level science questions, right? O1-preview did better than a human expert on PhD level questions, right? And weirdly did a bit better than O1, which is interesting. That said, I feel like with these benchmarks, there needs to be a bit of a rigorous as well examination of how these benchmarks are done, because we don't know if these models have been trained on the questions in these benchmarks. Because if it's trained, then it will likely do very well. Now, giving you a bit more here benchmarks compared to a lot other kind of areas as well when it comes to reasoning, right? So O1 does quite a bit better on like math benchmarks, for example, right? As you can see here on the left-hand side, right? Even does better on, mentioned the PhD level science questions. It did a lot better on physics than biology, for example. And then even on like calculus exams, the LSAT, so on and so forth, did a lot better as well, right? And you can see that mathematics is where you see the biggest gains compared to something like public relations or facts, right? For example, it shows kind of that reasoning aspect here as well. And so what I'm going to show, I'm trying to illustrate here some of those use cases. Everyone who doesn't have access to O1, maybe try this out as well in your own, your model as well. See if it works, right? Maybe we'll be able to like kind of contrast and compare what works and doesn't work, right? But the first example I'm going to use here is I'm going to create an implementation of the snake game, right? So my prompt here is, can you create an implementation of the snake game? It needs to be in HTML, and I need to be able to copy it into a single file and run it on my personal machine. Don't use any remote assets. So here what I'm trying to tell the model is that assume that there's no assets that are uploaded to the cloud that you can take advantage of, like images or something along those lines. And after opening the HTML, I need to be able to hit space to start or restart the game and provide me instructions on how I can run it on my own local machine. So I'm just going to copy this prompt here. And what I'm going to do just to make it easy for everyone, I have this online tool. Just I Googled HTML editor online, right? That lets me render HTML online just so I can show everyone so I just don't have to go through kind of downloading it and all of these things, right? So I'm going to go to O1-preview right now, right? So this is it. If you want to access it on your own machine, pick between these models. Again, you need ChatGPT Plus to be able to access O1-preview, right? But usually what you'll have is GPT-4o. You can go to for O1. I'm going to use O1-preview for the remainder of the session, right? But there's also O1-mini, which is a bit faster but less performant than O1-preview. And then there's other, legacy models here that you see. So O1-preview, I'm just going to paste this right here. Can you create an implementation of the snake game? It needs to be in HTML. And I need, so let me just remove myself here from, let's try to see. Yeah, that's great. Don't use any remote assets after opening the HTML. It needs to be, I need to be able to hit space to start or restart the game and provide me instructions on how can I run it in my own local machine. So I'll just press it here. It's thinking. And we can see here. So decomposing the problem, right? Crafting the snake game for local play in one HTML file, blah, blah. So I'm setting the rules for the HTML file. It must be browser compatible and seal clear of any copyrighted material exceeding 70 characters. Crafting the snake game. Okay. Constructing the framework. Mm-mm-mm-mm. Coding the snake game, mapping out the game. I'm working through the map and initiating the snake game. The player controls the snake's direction with the arrow keys, so it should be directable with the arrow keys, and start the game with the space bar. And here is the completed code. I don't know HTML, so I'm not going to be able to review this very well. But what I'll do is I'll copy the code, and we'll see if it works. So here, select all the code and above, and then here it's giving me instructions on how to do it on my own personal machine. But given that I showed you that editor here, so all I need to do is just delete this section here and then paste the code. And then we see here, we have a file with a score. So I press here. I'm going to press space. So it doesn't seem like it's doing what it's supposed to do here because I can't control it with the arrows. So here I'll just say, I can't seem to be able to control it. Can you debug? Okay. So let's see. What it did is that your flex key is the arrow keys. The problem is likely due to the use of the e key code function, which is deprecated in modern browsers. Instead, we should use e key or e code to detect key presses. Let's see if that works. So I'll copy the game again, and I'll go back to my HTML editor. Seems like, that is odd. Still not working. Let's just make sure that it's pasted in. Okay, I'll try it one more time, but then I want to make sure that we move on to the next set of questions. I have to say, O1-preview is not really impressing here. The arrows. The game needs to be playable. Okay, it's trying to test another issue here. See if it works. So what changed? Okay, add game over flag, improved reset function. Okay. Now let's try again. I go back here. Gonna refresh this page just in case there's any caching. Let's see. Press space to start. It seems like there is seems that the issue is related to how ChatGPT here is coding in the state of the game, which is leading into bug. That said, we can definitely like solve this, but I want to make sure that we have time to build our application, right? Uh, Funnily enough, it did work when I tried this exact same prompt 30 minutes before the code along. Uh, Another example that I'll show here of a tool is from someone on Twitter, for example, who used the Cursor AI um, uh, ID and O1 to essentially build in Swift a weather app, right? So essentially using only natural language of editing code and creating code, right? Um, this individual reached a point where he has a pretty stylish weather app, as you can see here. So while there is debugging that needs to happen here, right? The code being like the possibilities of prototyping applications is very, very interesting here. So here, someone is saying, tell it that it's doing that behavior. Upon trying it, the game stops each time I press space. So here, Dewan is telling me to try. Okay. Let's see here if what we have changed. So still having the same issue. So we need to hear, if I was an HTML expert, I'd be able to debug it myself. But this is the power, actually, the like, very good illustration as well of the importance of that it is breaking down here. Cool. So with that said, let's continue on with the actual prompt along. Any questions maybe first before we actually go along to the prompt along, where we try to build a financial analysis web app here using O1. Seeing some comments. So from Amjad, I think to make the app, we need to use HTML, CSS, and JS. That is true. Trying to simplify it as much as possible to be able to run it on HTML. And then, yeah, I think we definitely, like, for this use case of the snake game, someone's commenting here that it often happens. They would need to update, continuously have an iterative loop. Definitely agree. We just need to be able to be mindful of time. So with that said, let's jump in to the meat of today's discussion, which is on building a financial analysis tool. Now, we have two notebooks for you here. One of them already, I've tried the same prompts, and you can see all of the code, right, that we built. So all you need to do is just run this notebook to be able to see the code that came out with O1. But what we're going to try to do is also do it from scratch. And here we're going to, if we ever have bugs, we're going to try to debug the code. To be able to code along as well, what you need to do, you'll have access to this notebook. You just need to be able to press file and save a copy in Drive. And that way, you'll be able to code along yourself, right? We will be using an API, public API, for something called FinHub. I'll make sure there's instructions at the bottom on how to use the API as well. So once we reach that point, though, we'll get to it. Now, that said, the first thing that I want to do is a stock price visualization tool, right? So what we're gonna the prompt that I'm gonna use is, so maybe I'll first show it here. I would like to build a stock price visualization tool using Python. The outcome of this application needs to be an interactive visualization that is embedded in a Google Colab, where there are two drop downs, one for a given stock and one for different time horizons. So 1 month, 3 months, 6 months, etc. Use Matplotlib and Seaborn for the visualization and Yahoo Finance to access the data. Please provide me detailed instructions on how I can paste the code into a Google Colab. So I'm going to go here to a new ChatGPT prompt, a new ChatGPT chat. I'm going to open preview. I'm going to paste in that prompt, and then we'll see what we get out of it. So here, it's going to create an interactive stock right using Matplotlib and Seaborn embedded in Google Colab with a dropdown for stocks and time horizon. I'm detailing how to establish a Google Colab environment, import libraries. It's going to utilize IPY widgets for interactivity, right, which is great for a notebook environment, and fetch stock data from Yahoo Finance, and then plot using Matplotlib and Seaborn and employ widgets for selecting stock and time horizon. I'm organizing a step-by-step guide for how to open the project in Google Colab. And what I want to illustrate by this is that by asking it to do a step-by-step guide here on how you can use Google Colab, even if you've never used a notebook, you can suddenly have a tool that helps you guide you along the way, which is really great. So first thing, open Google Colab, file new notebook. We already have a new notebook. And then we need to install our library. So I need to install Yahoo Finance. I need to import Matplotlib, Seaborn, SNS, Pandas, SPD, datetime, IPython display, and IPY widgets, right? So here it's helping me define a few stock symbols. So that's step 3. So my stock options are Apple, Microsoft, Google, Amazon, and Tesla. And then we have a 1 month, 3 months, 6 months, 1 year, and 2-year time horizon, right? So here it's giving me instructions that I'm pasting this code into a new cell and running it, right? Then it's helping me create a drop-down widget. So here with IPY widgets, so I have widgets.dropdown. We have the stock options, which are in this list. And the value is, the default value is Apple. And then we have the time horizon dropdown, which is the same thing here. And it's using the keys, right? And then here what it's doing, it's defining functions. So it's defining a function to fetch and plot the data. So first thing is plot the stock data. The inputs are the stock symbol and the time period, right? So the end date is always today, and the time between difference, the delta days, is the time period input, right? And then start date equals end date minus time delta, okay? Then it's fetching the stock data. It's resetting the index of the data, and then it's plotting that data. And then it's creating an interactive output. Okay. And then it gives me the entire code here to be able to copy. So I'm going to copy this entire code. From a high level, it seems like this first set makes sense in Python, but we'll see if we get any errors, but we'll be able to troubleshoot it. So we'll go back here. I'm going to use code, right? And I'm going to put in a few blocks of code here, right? So first thing, I'm just going to install any relevant libraries. So first thing, I'm going to run this. It's running in quiet mode, so I shouldn't get a lot of output. To be able to run a cell, just hit Shift Enter or press Run on here. This play button here that you see, that's Run. And then here I'm going to import the libraries, right? So I'm going to also put this in another code cell just for the cleanliness of it all, because if I run it over and over again, it doesn't need to be rerun. So all of my libraries have been imported correctly. Then I have the list of stock symbols here, and I have the dictionary of time horizons. We created the drop-down widgets. We created the time widgets, right? And then I'll put this as well in another code block. So here it's like we're defining kind of the inputs, like kind of the building blocks of this code. And then here we have this function that we've defined that lets us fetch data and visualize it. And here we're just displaying our interactive plot. So let's see if it works out and how it ends up looking. Actually, it works relatively perfectly. So I have Microsoft here. That's also changing. All right, so let me zoom out a bit just so everyone can see it. I go back 3 months, 6 months. So you can see here 1 year, correct? And 2 years. What a good time to hold Microsoft stock. Google as well, 2-year horizon. So here, a question from Atia. The visualization will be as good as the one generated by Power BI? If so, can it replace Power BI? So I think the two questions here. We always have the capabilities to update the visualization. So one thing I can do here right now is try to update only the plot stock function, right, to set a better style. And I'll actually ask ChatGPT to do that. But then can it replace Power BI? Well, here it's also a question of usability and the stack that you have within your organization, right? So here we're working on publicly available data, right? Um, but what we if you're working with your own data connections within your own organization, right, then probably like connecting it to Power BI is easier in this context if you already have data models. And then I think Power BI will, it already has Copilot, but it will get better over time as well. You'll be able to build these visualizations with natural language like I just did in code, but using Power BI. So what I'm going to do here, though, to answer your first question on can we improve the visualization? So I'm just going to say here, great job. The visualization worked, but I would like to improve the aesthetics of the line chart in the following function. Can you make it a bit more aesthetic by... So what are ways that we can make this visualization a bit more aesthetic? Removing grid lines, making the line chart a bit thicker, and adding a label. So here we have closing price and day, and aligning the title of the chart on the left-hand side of the visual. Question here from Violo. Does Google Colab and Jupyter Notebook work the same way? Generally, yes. You may have to install some stuff on your Google Colab. So here it updated the function. So hopefully if I just update this, the entire code should remain the same. So here we just updated some formatting, right? So what it's done, it set the style to white, removed the grid lines, made the line thicker, aligned the title to the left, and then let's see. Okay, yeah, you see it here, right? Gold stock price, so on and so forth, right? The possibilities are endless here. You can give it its your own color scheme. You can give it your own font potentially, right? There's a lot that you can do here. Now, the next thing that I want to do is I want to refine this visualization tool to also include some useful um, uh, measures that a finance team would use here, right? Like simple moving average, for example. So here, what it does calculates the average of selected range of prices, right? And then, or exponential moving average, or Bollinger Band's definition, right? So I'm not a finance expert. If there's a finance expert here, please do point out if my definitions are wrong, right? So exponential moving average gives more weight to recent prices, for example. And then Bollinger Bands are essentially two outer bands that set two standard deviation above and below the price, right? And they measure market volatility, right? So what I will do, I will now say, so if I go here to ChatGPT, so I won't actually include the definitions of these measures. I will just say, can you help me update the script by adding date pickers for custom data ranges, sorry, and a drop down for different indicators to visualize. Please provide a simple moving average, exponential moving average, and Bollinger Band. So I'm not only adding additional measures, I'm adding custom date ranges. So I'm able to want to be able to do it from one day to another, choose my dates as well. So let's see how it does. So adding date pickers here and a drop down for SMA, EMA, and Bollinger Bands. Updating the strip to swap the time horizon with date pickers. Okay. Okay. Let's see how we're doing. First step, we already have all of our packages. So I'll just also start building the code here. I'll come back to the ChatGPT. I just want to make sure that we. Okay. So we already have Y Finance installed. I'll just paste the library imports. I think all of our libraries are still there, minus as well. I think what we're missing is I'll just keep them as is, but usually what you want is to consolidate all your library imports from the beginning. Then we have the stock picker. Okay. So same thing here as we did, stop drop down. Now we have the start date picker and the end date picker. So, and you can see there are widgets date picker, right? So these are specific widgets. Now we have indicator drop down. So closing price, simple moving average, and there's a drop down here. Now what it does is updates the plot function, right? If start date above end date, start date must be, it returns an error. So I already caught that. And then if data is empty, then no data available for the selected date range. And then if the indicator is SMA, then you do a rolling window 20 on the close price of with a mean, right? Then if the data indicator is exponential moving average, so then we have the EWM function that we're using, and we're using a mean. And then if it's Bollinger Bands, we calculate the simple moving average, we calculate the standard deviation, and then we define the upper band and lower band. So it does seem like, statistically speaking, from on the fundamentals, we are doing this correctly. And then we do line plots here depending on the indicator, and then return title labels, so on and so forth. So what we'll do here, so it seems like what only things that have been updated are the actually, I'll just paste the entire code here if it's easier. So this is the full updated code, right? And what I'm hoping that I'm able to show with this process or kind of this workflow that I'm using is that I'm building a V1 and I'm improving on the V1. And then if I can further choose to improve on that V2 that I built, right? So here, stock dropdown, date pickers, then indicator widgets. So these are the widgets all defined here. Then my function is here. And then my displayer is here. So let's import the packages. Most of them have already been imported already. Now I'm defining the stock dropdown, the date and the start date and end date picker, and which indicator I'm using. And then I'm plotting my data with these functions, right? And now I'm displaying the visual. Okay, so now we have closing price. So what stock I'm using? What is the start date? Okay. It seems like the first error was maybe due to the same dates being used. And then I'm changing my measure. Simple moving average, you can see it here, right? Exponential moving average, moving here. Bollinger Bands. You can see upper band, lower band. I just want to ask the group here, if you are doing this in Excel, how much time would this take you? Right? It would take quite a bit. Now, I want to try to build something new here. I'm going to deviate away from my from the use case that I'm building. And I'm going to actually look at another source of information that I would, that hedge funds usually use, which is, what is the sentiment of financial news about a given stock? And we're going to use a free API. And when it's free, it means it's not going to be fit for purpose, right? We're going to use something called FinHub. To get the FinHub API, all you need to go is, oops, sorry, not this link, but finhub.io. Just go to finhub.io. Then get free API key. And then put your email and you'll get an API key, right? And then you'll be prompted to ask your name, email, and password, right? Then you copy the API key that you get. Then you come back to the Google Colab, right? You'll press on this key button. You input the name of your API key. So here I'm calling it FinHub API. And then the API key, you paste it into here. And then make sure that provide notebook access, right? And then to be able to get your API key, you just use this function here. I'll show you how. I'm defining it as FinHub underscore API equals user data.get. And what I'm going to do is get, the free API allows us to only return one stock and 5 news stories about that stock. And given that we're only looking at titles, not the content of the articles, sometimes we may get, titles that are not necessarily related to the stock, but the content of the articles may be related, right? So I'm building something very simple here. It's not going to be necessarily extremely useful, but it also shows the illustration here that I'm trying to do. So I want to build a simple financial news sentiment analysis bot that analyzes headlines from financial news articles using the FinHub API. The outcome needs to be a data frame with 4 columns: the stock, the date, the title of the article, and the sentiment. So I'm just going to copy this prompt. Okay. I'm going to paste it here. Right. I'll remove the link here just to not create confusion. And let's see how it performs. Okay. So it's going to use NLTK, okay, which has like out of the box functions for sentiment analysis. So here it's really interesting, right? I'm piecing together a strategy to verify code accuracy and reliability, particularly for factual correctness and avoiding hallucinations. This approach boosts the quality and reliability of the assistant's output. So it is the assistant. Okay, so it's telling me what I need to do. Go to FinHub.io, log in. So I need to make sure that I have requests installed. That's my first step. Now I'm importing my libraries. So here it's telling me put your API key equals your FinHub API key, right? I'm just going to paste here this code. From google.colab user data, FinHub API equals user data get FinHub API. So here, fetch news about the stock symbol from the last 30 days till today. The URL comes from the stock symbol news from date to date token equals API key. That seems to make sense. Get the response URL. If else, failed to fetch news. Then we do another function to analyzing sentiment. So if I go back, so if you notice something, I'm going to do a bit of an edit here, right? Here it says API key, right? I just need to replace this FinHub API key, and now it should work. Function to analyze sentiment. So this function here, what it does, creates a sentiment intensity analyzer, gives a score for a headline, and then provides the compound score. So here this creates the data frame. So what I'm using here, so I fetch news for the stock symbol, so for Apple, let's say, and then for any article in the list here that is generated, we get the time date, we get the title, we get the sentiment by analyzing the sentiment, and then we append the stock symbol date, and then we return it as a data frame. This does make sense. And then let's test it out. Let's test this entire system out. Stock symbol equals Apple. I'm getting the news sentiment for the Apple stock, and I'm going to show the first 5 rows. Actually, I'm going to show all of it because it's all going to be 5 rows, I think. Okay, actually, no. I'm getting 223 rows. Amazing. So you can see it here. So just do it brand name. Let's pull this up. Just do it brand name lessons from Nike's Troubles. So Nike's Troubles sentiment 0.5. According to FinHub, this is somehow associated with the Apple stock, because if you look at the URL, it has company news symbol equals stock symbol. So we're only filtering for the Apple symbol, and this news seems to be tagged based on Apple, right? Then why Apple stock is trading lower today? Negative sentiment, right? Apple falls as analysts debate iPhone demand trends. Negative sentiment. So in just 2 minutes, we were able to build a sentiment analysis bot that gives relatively not bad signal to noise ratio, right? Where we're able to get Apple news that is relatively useful from a financial services perspective, right? And this really shows here the power of kind of using a copilot like that for a coding use case. Now, someone do ask as much questions. We're going to have questions at the end. We're probably going to be running a few minutes late. Someone asked, is it necessary to use Google Colab, or is it better to run in a local environment? So it really depends. I'm using Google Colab just to be able to give you access to your machine. And then Violo, does Google Colab and Jupyter Notebook work the same way? I feel like Colab has a few additional functionality, like because it's cloud based, and on your local machine, you probably have a lot more control over how you install things and what you install. So maybe some stuff doesn't work out from today because of like installation or versions. Okay, and with that, we built right a system in less than 30 minutes, a tool in less than 30 minutes that visualizes, gives our stakeholders the ability to visualize stock data and price data across different measures, right? And then gives us an overview over sentiment of Apple stock, right? And what I want you to think about here, if you are able to use your own organizational data or your team's data in this context and provide visibility, create a web app that is useful for your team, think about what is possible here. And with that said, we can transition to the next section, which is when to use O1 versus other models, right? Um, I think there are some important consideration, right? So latency, how fast do you want the responses to be generated, right? So for example, if you're building a chatbot that answers simple questions like what is 1 + 1, long latency is probably a bad user experience here, right? Complexity, like how complex is the problem? If you're just writing a draft for an email, don't use O1 here, right? And then quality of responses, how accurate is the model? Like, is 80% of the time good enough, or should it be 99% of the time, right? And then just to note here, all models hallucinate. You saw, and the kind of we start off on a bit of a bad foot with O1, didn't work out with the snake game, right? And then this is specifically for the API, right? But also, you saw here to be able to access O1, you need a team subscription, especially if you're using the API to build a system, right? Uh, O1 can be extremely expensive, right, compared to other models. So use O1 if you care about high quality responses. The tasks are pretty complex and open ended. You don't have inference consideration, so you can wait a few seconds on a response, and you can afford it for your application if this is API based. Use 4.0 or below if you can settle for high but not the highest quality responses. Your tasks are relatively simple. You need the answers fast, and you care about being cost effective. This is an API focused consideration. Okay. Um, and with that, some closing notes and Q&A. I showed this with the snake game, right? I showed this while looking at the API key and fixing it. Even as models get better and you need to edit less, never forget the importance of a human in the loop. It's extremely important to edit and own the outcomes from the model. And then as we look at generative AI and the future of work, right? There's always, big chatter about, how AI um, is growing to be more of an existential threat to the species, right? And while I don't think that we have reached that yet, right, I think it's also really important to think about what the future of AI looks like, um, and how we can work with AI effectively. There are two visions that are being painted here. The first vision is that of existential risks and Terminators destroying the world, and the other one here of a useful robot helping a construction worker. And if you look at what we've done today, we worked with an automated system to build something we want built, right? What was automated was the task of coding, not the uh, outcome or the benefits or how we can approach the problem here, right? And our own guidance is also extremely important. And so when we think about the real risks of AI, especially the real short-term risks, it's something like scalable misinformation, right? Here's a picture of former President Donald Trump being arrested by a bunch of police officers. That did not happen. Or scalable bias perpetuation. Here, and this is a very early version, I think ChatGPT 3.5 here, where someone asked ChatGPT to write a function to predict seniority in a role based on race and gender, and you can guess what was the response. If someone is a person of color and they're female, it returns junior. If it's person of color and male, mid-level. If it's white and female, mid-level. If it's white and male, senior, right? Else return junior, right? So what are the implicit biases that can be encoded in the solutions that we're building, depending on the use case, right? Maybe if you're building a financial news analysis tool, there's no room for bias, right? You're analyzing stocks. If you're working with healthcare data, if you're working with demographic data, these are all important aspects here. And then scalable security, cybersecurity risks and threats, right? Um, so, for example, if you ask ChatGPT to write you an email from a Microsoft account services asking for a password reset, it can do that. So that's something to think about here as risks of these systems. And with that, some principles for success in this time of innovation: embrace change, use it for your own advantage, right? Uh, Beware of the real risks and become a more digitally engaged citizen. And tools like ChatGPT and generative AI can really augment the roles of today and will transform them for the future. And with that, I'll be super happy to take some Q&A. I really appreciate those who are sticking extra, and totally appreciate if you have to leave now. We'll make sure to send over the recording, and I hope you found it useful. So another question that we had here from Atia. The visualization will be as good as the one generated by Power BI. If so, we already answered that question. But then here, if I have a choice with which one I should go for, should it be ChatGPT or Power BI? Well, it depends on how you want to share it, right? Do you want to share a dashboard with your stakeholders that everyone can access, right? I think here Power BI is useful. Then John, is it necessary to use Google Colab, or is it better to run it on a local environment? It's really as you wish. I used Google Colab just to be able to show you and share the code, all of that. Is Copilot a separate feature compared to ChatGPT O1-preview? It is. Copilot is from Microsoft on the Windows machine. ChatGPT is owned by OpenAI, and Copilot can be used also for Power BI and something along those lines. So different companies, but using the same technology. Bruno Vincent, what's sentiment? So sentiment is like whether, if you look at here, whether the title shows a positive sentiment or a negative sentiment. So if Apple, for example, is trading low today, that's a negative sentiment. So, and you see here it's minus 0.296, right? So, for example, Apple iPhone 16 availability suggests weak demand by Barclays. So that's a minus 0.5. So I think it's from -1 to 1, -1 being the most negative, 1 being the most positive. How does O1 compare to Claude's AI model? So I think on O1 on raw reasoning tasks is better than Claude, if I'm not mistaken. But what I do love about Claude's the artifacts feature. Um, for those who are not aware of that, highly recommend that you check out this article that we have. So I'm just gonna Google it: DataCamp Claude 3.5 artifacts. Yeah, Claude Artifacts 101. Um, really beautiful. So actually, I'll share my screens here. Um, Really beautiful feature, in my opinion, that really kind of transforms the user experience of a chatbot. And what artifacts are essentially is you're coding here, you're chatting in chat and Claude, and then it lets you render an application in real time. So you saw what I did with the snake game. I copied it, put it in HTML. Claude has its own HTML rendering, engine, and like React rendering engine. So, for example, here someone said, can you create? Yeah, so that's here. Create a presentation with the information above. It's able to create a slide deck, right, using React. Can you create a visual? And it's able to create like an interactive visualization, right? Can you create an SVG graphic, right? Can you create a website? You're able to browse the website. So it's a really beautiful, in my opinion, feature. And it would be crazy if OpenAI doesn't build something like that. Another question here. In which domains do you recommend to use O1 instead of ChatGPT 04? ChatGPT 4 here said 04. I would say that anything that requires like complex coding, I would use O1 for it. Am I working on any personal projects using O1 at the moment? Anything you'd be willing to share? Actually, I'm not. I'd love to, but my full time job takes all of my time. But that said, what I use O1 for a lot is to build a lot of our own internal reporting on the media team. So uh, whether we've created a lot of internal dashboards using Python that connect our own data that have really changed the game with how we make decisions and created visibility over things we haven't had before. So here, how good is Colab's option for us to use generative AI to code for us? So I think it's using Gemini in Google Colab. For example, DataCamp Data Lab is. We also have a tool similar to Google Colab here, and we use GPT-4o. I think pretty solid performance, but you're not going to see that same level of like breaking down tool complex code into multiple problems, and the way that O1 approached it. Another set of questions here. Can you suggest a few other use cases for O1? I would recommend using O1 as well for areas that you're not necessarily used to, such as building maybe applications or learning how to build Swift applications for iOS, right? Because what's really impressive about O1 is that if you tell it, "I am a noob, give me detailed instructions over how to deploy it, how to like run it, what should I install, what should I not install," it will actually be very helpful here. And I think this wraps up today's session. I'm really sorry we went 10 minutes over time. That pesky snake game took a lot of time to debug, and we still haven't debugged it. But I want to say a huge thanks for everyone who attended today's session. It's been an honor, a privilege. Really, really appreciate it. And on to the next one. And I'm very excited about what we're ahead. We announced DataCamp Radar Forward Edition today. And make sure to register for that one. I'm also very excited for the upcoming set of code alongs and webinars we have. So stay tuned for those. And with that, I'll give everyone